Hi, good day to you, and welcome to my channel where I tutor you in science for free. The topic in this video will be thermal properties of matter. So in this chapter, we'll be covering on how to account for all the energy changes that is taking place inside a matter. So firstly, we would like to understand what is internal energy. So we will be already very familiar with atoms moving around. That's kinetic energy. So particles have kinetic energy. They gain heat, they vibrate faster, move faster. And they also have this thing called internal potential energy from the stretching and compression of the bonds as particles move and the energy stored in these bonds. And all of these will account for the internal energy a matter have. And so first up, we talk about heat capacity. Heat capacity is defined as such, the amount of energy, heat energy required to raise the temperature of a substance by 1 Kelvin. And a movement of 1 Kelvin division is also equivalent to 1 degree Celsius. And formula is as such, Q equals to C deta. And this triangle stands for the change of temperature. Deta stands for the temperature. And because of this, if you move them around, then the heat capacity will look like that as a fraction, Q over change in deta. And the units will of course take the shape of this fraction, which is joule per Kelvin or joule per degree Celsius. So similarly, it is another formula whereby you can just see a question, do an extraction, which we will run through later, throw formula, plonk in all the values, and you should be able to get your answer. So this is yet another chapter that gives you a formula. Similarly to heat capacity is the specific heat capacity, where it's defined as the amount of heat energy required to raise the temperature of a certain unit of mass, like a gram or a kilogram, by 1 Kelvin. So specific heat capacity is mass dependent, and the formula will be Q equals to mc change in deta. Changing it up, it will be C Q over m change in deta, which is joule per kilogram per degree Celsius, or whichever unit of mass or temperature is given to you. Specific heat capacity of different materials will stay the same, whereas heat capacity will change accordingly as the mass increases or decreases. So these are the subtle differences. So with the formula out of the way, we will go through change of state. Firstly will be melting. Melting is the change of state from solid to liquid. So as the particles are held together by strong bonds, you already know all of this, packed closely together, the internal potential energy is lower than liquid. So as heat is supplied, the heat energy is absorbed, breaking these bonds, overcoming these bonds, and they are now free to move around, move away from their fixed positions. And do note that in pure substances, at the point of change of phase or change of state, like melting, the melting point or boiling point will be constant. And why is that so? Because all the energy is used to increase the total internal potential energy to break the bonds. All the energy is used to break the bonds. None of this energy is used to convert to kinetic energy. Therefore, there is no change of temperature during the melting. And the reverse process is the same, occurs at the same temperature. So melting, the opposite of melting will be solidification or freezing point. Common substance like water melts at 0 and freezes at 0. And similarly, internal kinetic energy does not change. Only the internal potential energy decreases because the liquid molecules are losing energy. They are coming together to form intermolecular forces of attraction to achieve a closely packed position in a solid that you are familiar with. And so cooling curves will look like that. Same, the pure substances freeze at a common temperature. Similarly to boiling and condensation, pure substances will also boil at a constant temperature and condense at a constant temperature. Okay, because we are talking about boiling and melting, we will need to cover latent heat and specific latent heat. Latent heat is the energy released or absorbed during change of state without change of temperature. So same, latent heat of fusion, heat required to change a substance from solid to liquid without change of temperature. And similarly, because the word specific, for specific latent heat, because the word specific is there, unit of mass needs to be accounted for. And also there will be another formula which is like that. So latent heat is equals to specific latent heat multiplied by mass. So therefore, if you move it around, specific latent heat or fusion will be latent heat, which is an energy, a form of energy, joule per kilogram, or per whatever mass that is given in your question. And also, similarly, latent heat of vaporization, amount of heat energy, change substance from liquid to gas without changing temperature. Specific latent heat of vaporization is the same. You need to take into account a unit of mass. Formula is very similar and units are also very similar. Okay, lastly, we will talk about evaporation. This is something we should be very familiar with. And the common comparison we would like to take note is the comparison of evaporation versus boiling. And these are the list of differences. So of course, boiling point, it only occurs at a particular temperature, at one temperature, while evaporation occurs at any temperature. So how does it work is at any one point of time, the molecules at the surface of the water gains enough energy, it will overcome and the intermolecular forces of attraction and escape into the air. Changes are only happening at the surface, therefore it is relatively slow. And boiling produces bubbles from the heat source, while evaporation does not. And boiling, you require an external heat source, while evaporation does not. Okay, and these are 6 factors that affect rate of evaporation. So if you have high temperature, of course, you will evaporate faster. Molecules, they gain in energy. Humidity of surrounding air. So if there is high humidity in surrounding air, the chances of water molecules diffusing out of the system is lower because the concentration gradient is a little bit lesser. Surface area, of course, if you spread the water across a large surface, it dries faster, just like mopping the floor. Okay, boiling point of the liquid. So of course, if it is lower than the surrounding temperature, it's going to lower boiling point as compared to the surrounding temperature. It is going to evaporate a lot faster because the energy from the surrounding is being absorbed by the liquid to carry out evaporation. Movement of air, so things like wind. If there is higher level of wind, then evaporation is going to be faster because the newly evaporated molecules do not hang around near the water source, and therefore it's a little bit like diffusion. So the water molecules are more likely, more encouraged to evaporate, like to diffuse out. Okay, pressure. So pressure, like mentioned in the pressure chapter, is quite a funky concept. It's difficult to relate to, but you just imagine that there's a lot of pressure is a little bit like humidity. If there is a lot of vapor, a lot of air particles pressing down onto the water surface, the molecules of water in the water body is not likely to leave the system. The probability is much lower. So reducing pressure will increase rate of evaporation because there is lesser particles hitting the surface of the water, and therefore the surface water molecules have more room to escape. So applications of evaporation are as such, perspiration being one of them. And do note that water molecules can carry a lot of energy. So when they evaporate, they take away a lot of energy, heat energy from the surface of the skin, therefore cooling you down. Refrigerators, and also the refrigerators uses this concept to keep contents cold. Okay, let's look at some questions. Hand dryer blows hot air. In 1 second, 75 grams of air enters, gains 2000 joules. Specific heat capacity of air is such. What is the expression of temperature rise? So temperature rise is just change in detail, and the rest are given. So you throw in your formula and you move things around. This is what you will get. A block of copper at room temperature. A smaller block of copper at room temperature will have which of the following attributes? The internal energy will be less because it's a smaller amount. As a smaller size object, the amount of matter and energy that it contains is going to be lesser. Heat capacity will therefore be lesser. However, specific heat capacity will always be the same because it is the same material. Okay, so swimming pool of this size. Heater increases temperature of water from this to this in this time. Density of water is this. And because this chapter requires a lot of formula, and pretty much you're forced to merge this one formula together. That's called energy equals to power times time. You will learn in future chapters, or is it the previous chapter? So Q equals mc liter. Find the volume first, density, use the density to help you get the mass, throw in everything, then you get the amount of energy required, and then you have E equals to PT. Your Q is literally the same as E, so you can just sub it in, and the time is usually in seconds, and this is what you get. Okay, explain difference between heat capacity and specific heat capacity. This is just definition question. Calculate total energy required to raise temperature of water and cup from this to this. So Q equals MC liter, Q equals MC liter, and add them together, throw everything in and add them together. Energy of liquid decreases, change into solid at melting point, or rather freezing point. Okay, explain. So forming of intermolecular bonds decreases potential energy, no change in internal kinetic energy, therefore no change in temperature. Okay, ice cube tray with water becomes ice. And these are the following information given. Calculate total energy removed from the water. So there are two parts. From 20 to 0, you need to calculate that, and from 0 liquid to 0 solid. That is the heat of fusion, latent heat of fusion, right? So Q equals MC liter and also LFM. Then dump everything in and you will get answer. Okay, this is a heating graph. Of course, it is, you can see two straight lines there, means it changed from something to something and to another thing. Likely is from solid to liquid, liquid to gas. So which 2 points does beaker contain mixture with liquid and solid? You have to choose the one whereby it is flat. So the earlier one is just solid, then solid to liquid. So it's going to be WX. Then X and Y will be just liquid. Then X and Z will be liquid and gas. And that is all for today. Hope you enjoyed this video. Do give it a like and subscribe, and share it with somebody who needs to see this. And I will catch you in the next video. Bye!